Hi everyone, welcome back to our channel. Last video we have already discussed on the fundamental theorem of arithmetic and the examples related to it. If you have not yet watched, please do watch. In this video, we will be solving the exercise 1.1 problems. So without any delay, let's get into the video. Exercise 1.1, question number 1. Express each number as a product of its prime factors. So question number 1 is 140. So let's express 140 as a product of prime factors. So the smallest prime number that can divide 140 is 2, giving 70. Again 70 is divisible by 2, giving 35. Now the smallest prime number that can divide 35 is 5, giving 7. And 7, since it's a prime number, it is divisible by itself. So 140 can be written as 2 into 2 into 5 into 7. So this can be simplified as 2 square, since 2 appears 2 times, into 5 into 7. Now let's look at the second problem, that is 156. So 156, the smallest prime number that can divide 156 is 2, 7 2s are 14, carry 1, 8 2s are 16, again 70, it is divisible by 2, that is 3 2s are 6, carry 1, 9. This next smallest prime number that can divide 39 is 3, giving 13. Since 13 is a prime number, 13 is divisible by itself. So we can write 156 as 2 into 3 into 13, that is 2 square into 3 into 13. Since 2 appears 2 times, we can write it as 2 square. Now the third question is 3825. 3825, the smallest prime number that can divide 3825 is 3. 3 1s are 3, 3 2s are 6, carry 2, 7 3s are 21, carry 1, 5 3s are 15. Again, this 1275 is divisible by 3, 4 3s are 12, 3 2s are 6, carry 1, 5 3s are 15. Again, 4 to 5. Now, 4 to 5 is divisible by this next smallest prime number, that is 5. 8 5s are 40, 2, 5 5s are 25. Again, 85 is divisible by 5, giving 5 1s are 5, 6, 7, 8, that is 35, 7. 17 is a prime number, so 17 is divisible by itself. So we can write 3825 as 3 into 3 into 5 into 5 into 17, that is equal to 3 square into 5 square into 17. Now next question is question number 4, that is 5005. So the smallest prime number that can divide 5005 is 5. So it gives 1001, which is divisible by 7. 7 1s are 7, 8 9 10, that is 3, 7 4s are 28, 29 13, again 2, 7 3s are 21. So 143. Again this 143, next smallest prime number that can where 143 is divisible is 11. 11 into 13 is 143. 13 is again a prime number, so 13 is divisible by itself. So we can write 5005 as 5 into 7 into 11 into 13. 7429. So the smallest prime number that can divide 7429 is 17. 17 times 437 gives us 7429. Now this 437 can be divided by the next smallest prime number, that is 19. 19 times 23 gives 437. 23 itself is a prime number, so it is divisible by the number itself. So 7429 can be expressed as the product of 17 into 19 into 23. Let's move on to the next question. Question number 2. Find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of the two numbers. So first problem, 26 and 91. Let's write 26 as the product of its prime factors. So 2 is the smallest prime number that can divide 26. It gives you 13. Again 13 is the prime number, so 13 is divisible by 13 itself. So we can write 26 as 2 into 13. Now what about 91? The smallest prime number that can divide 91 is 7. It gives us 13. 13 itself is a prime number, so 13 is divisible by 13 itself. So we can write it as 7 into 13. So what is HCF? HCF means it's a product of the smallest power of each common prime factor in the number. So the common prime factor in the number is 13 and there is only 13. So what is the smallest power of 13? It is anyway 1. So the HCF of 26,91 is equal to 13. Now what about the LCM of 26,91? So LCM means it's a product of the greatest power of each prime factor involved in the number. So here it is 2 into 13 and in 91 it is 7 into 13. So 13 is also already here, so we have to write only 7. Now we have to take the greatest power of each prime factor involved in the number. So the greatest power is for every number is 1 anyway, right? So we can write 1, 1, 1. So here we can find the product 14 into 13. So 14 into 13 is equal to 182. So the LCM of 126,91 is 182. Now let's verify LCM into HCF is equal to product of the two numbers. So HCF into LCM should be equal to 26 into 91. So here the HCF is 13, LCM is 182. Okay, let's find LHS 13 into 82, 182, 182 into 13, 3 2s are 6, 4 2 5 0, 2 1s are 2, 8 1, 6 6 3 2. So it is equal to 2366. Now let's see the RHS. RHS is equal to 26 into 91, right? So 26 into 91, 6 2 0 9 6 are 54, 4 5 9 2 is 18, 19 20 21 22 23 23. So it is 6632. So this is equal to 2366. Therefore LHS equal to RHS. Hence verified. Question 510 and 92. Okay, 510. Let's write 510 as the product of its prime factors. So 2 is the least prime number that can divide 510. It will give you 2 2s are 4, carry 1, 5 2s are 10, carry 1, 5. 255 is divisible by the least prime number, that is 3. 8 3s are 24, carry 1, 5 3s are 15. Now this 85, it is divisible by the prime number 5. 5 1s are 5, 6 7 8, that is 3, 7 5s are 35. Now 17 itself is a prime number, so 17 is divisible by 17 itself. So we can write 510 as 2 into 3 into 5 into 17 and 92. So now next is 92. 2 is the smallest prime number that can divide 92. 4 2s are 8, carry 1, 6 2s are 12. Again it is divisible by 2. 2 2s are 4, 3 2s are 6. Now 23 itself is a prime number, so 23 is divisible by 23 itself, because 23 has only two factors, that is 1 and the number itself, that is 23. So we can write it as 2 into 2 into 23, which can be simplified and written as 2 square into 23. Now let's find the HCF. HCF of 510,92, that is the product of the smallest power of each common prime factor in the number. So the common prime factor here is 2 as well as 23. So let's write 2 and 23. Now we have to find the smallest So HCF means we have to find the product of the smallest power of each common prime factor in the number. From these two, we can see 2 is the only common prime factor. Okay, and let's see what is the smallest power. Here it is 2 raised to 1 and here it is 2 raised to 2. So the smallest power of this prime factor is 1. So we can write the HCF is 2. Now let's find out the LCM. LCM of 510, 92. LCM means it's the product of the greatest power of each prime factor involved in the number. So let's take this. Here there is 2, 3, 5 and 17, and here the extra one is 23. So into 23. Now take the greatest power of all these numbers. Here the greatest power from both, if we check both these, it is 2. 2 raised to 2. Here 3 is anyway 1, 5 is 1, 17 is 1, 23 is 1. So the LCM is 4 into 15 into 17 into 23, which is equal to 23460. Now what we have to verify is LCM into HCF is equal to the product of the two numbers, that is 510 into 92. So LHS, this is RHS. So let's prove. Let's take LHS. LCM of 510, 92 into HCF of 510, 92. Let's take LCM is 23460 into HCF is 2. This will give you 0, 6 to the 12, carry 1, 4 to the 8, 9, 3 to the 6, 2 to the 4. 46920. Now let's take the RHS. RHS is 510 into 92. So let's find 510 into 92. 0, 2, 5 to the 10, 0. 0, 9, 9 5 are 45. So 02964, which is equal to 46920. Therefore, LHS equal to RHS, hence verified. Question number 3. Write 336 as a product of prime factors. So the smallest prime number that can divide 336 is 2. 2 ones are 2, carry 1, 6 2s are 12, carry 1, 168. 168 is again divisible by 2, giving 84. Again divisible by 2, giving 42. Again divisible by 2, giving 21. Now the next smallest prime number that can divide 21 is 3, giving 7. 7 itself is a prime number, so 7 is divisible by itself. So 336 can be written as 2 into 2 into 2 into 2 into 3 into 7. Now let's take 54. 54, let's write 54 as a product of its prime factors. So 2 is the smallest prime number that can divide 54, giving 2 2s are 4, carry 1, 7. So for 27, the next smallest prime number that can divide 27 is 3, giving 9. Again 9 is divisible by 3, giving 3. 3 itself is a prime number, so it is divisible by itself. So 54 can be written as 2 into 3 into 3 into 3. So 336 can be simplified and written as 2 raised to 4, as 2 appears 4 times, into 3 into 7, and 54 can be written as 2 into 3 raised to 3, as 3 appears 3 times. Now the HCF of 336, 54 is equal to, HCF means it's a product of the smallest power of each common prime factor in the number. So from these two we can know the common prime factors are 2 and 3. So HCF means it's a product of the smallest power. So from here it is 2. Here it is 2 raised to 4. So the smallest power is 2 raised to 1. In 3, if we check here, it is 3 raised to 3. Here it is just 3. So the smallest power is 3 raised to 1. So product of the smallest power of each common prime factor in the numbers, and the value is 6. So the HCF of 336, 54 is 6. Now let's find the LCM. LCM of 336, 54 is equal to, LCM means it's a product of the greatest power of each prime factor involved in the number. So the prime factors that are involved in the number 336 are 2, 3 and 7, and the prime numbers that are involved in 54 is 2 and 3, which is already written. Now we have to take the greatest power. Greatest power of 2 is 4. Greatest power of 3 is 3, and greatest power of 7 is anyway 1. So this will give you 16 into 27 into 7, which gives us 3024.
So LCM is 3024 and HCF is 6. Now we have to verify that LCM into HCF is equal to the product of the numbers 336 into 54. So let's take the LHS. LHS is LCM of 336, 54 into HCF of 336, 54, which is equal to 3024 into 6. So 6 4s are 4, 2, 6 2s are 12, 13, 14, 14 carry 1, 6 3s are 18, 18144. Now RHS is equal to 336 into 54. When we multiply 336 into 54, it gives you 18144. Therefore, we can say LHS equal to RHS, that is LCM into HCF is equal to the product of the two numbers. Hence, verified.
Question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. So let's find the HCF and LCM of these three numbers, HCF and LCM. So the first question, 12, 15 and 21. So 12, let's find the prime factors of 12. 2, it's divisible by 2, so gives 6. Again, 6 is divisible by 2, giving 3. 3 is a smallest prime number, so it is divisible by 3 itself. So we get 12 as 2 into 2 into 3, which can be written as 2 square into 3. Now 15, it can be the smallest prime number that can divide 15 is 3, 5 times 3, right? 5 is again a smallest as a prime number, so 5 is again divisible by the number itself. So we can write it as 3 into 5. Now next number is 21. 21, the smallest prime number that can divide 21 is 3. 7 3s are 21. 7 itself is a prime number, so it is divisible by itself. So we can write 21 as 3 into 7. Now we have to find the HCF. So HCF of 12, 15, 21. So HCF means it's the product of the it is the product of the smallest power of each common prime factor in the number. From this, this and this, we have to find the common term. The common prime factor here is 3. So let's take 3. Now we have to find the smallest power. Smallest power of 3. Smallest power of 3 is anyway 1. So the HCF is 3. Now let's find the LCM. LCM of 12, 15 and 21. So LCM means product of the greatest power of each prime factor involved. So here it is 2 into 3. In the next one it is 3 into 5. Since 3 is already there, we have to only write 5. The third one it is 3 into 7. 3 is already there, only 7 is missing, so write 7. Now we have to take the greatest power. The greatest power of 2 here is 2. Greatest power of 3 is anyway 1. Greatest power of 5 is 1. Greatest power of 7 is 1. So 2 2s are 4. 4 into 3, 12. 12 into 5, 60. 60 into 7. 60 into 7, that is 420. So the LCM is 420 and HCF of 12, 15, 21 is equal to 3 and LCM of 12, 15 and 21 is equal to 420. Second question, let's take 17. 17 itself is a prime number, so 17 is divisible by 17, the number itself, and 1. 23 is again a prime number, so we can write the factors of 23 as 1 and the number itself. 29 is also a prime number, so we can write the factors of 29 as 1 and the number itself. So now let's find the HCF of 17, 23 and 29. So the common among these three are the factor is 1. The common factor is 1. Now LCM of 17, 23 and 29, we take the product of the greatest power of all of each prime factor involved in the number. So let's take the first one, it is 17 into 1 into next one it is 1 into 23, so 1 is already there, let's take 23. The third one it is 1 into 29, 1 is already there, let's take 29.
So the LCM is 17 into 23 into 29, since all these greatest power is 1. So 17 into 23 into 29, which gives you 11339. So the HCF of 17, 23, 29 is 1, and LCM of 17, 23, 29 is 11339. Question number 3. Let's write 8 as the product of its prime factors. So 2 is the smallest prime number that can divide 8. So 4 2s are 8. Again 4 is divisible by 2. 2 2s are 4. 2 again divisible by 2 itself. So we can write 8 as 2 into 2 into 2, or it can be simplified and written as 2 cube. Now take 9. 9, the smallest prime number that can divide 9 is 3. 3 3s are 9. Again 3 is a prime number, so it is divisible by itself, and we can write 9 as 3 into 3. Or we can write it as 3 square. Now next is 25. 25, the smallest prime number that can divide 25 is 5. 5 5s are 25. Again 5 is divisible by 5 itself. So we can write 25 as 5 into 5, that is, or we can write it as 5 square. So the HCF, here there is no common prime factor in from 8, 9 or 25, there is no common factor. So our HCF is 1. Now let's take the LCM. LCM means we can take the greatest power of each prime factor involved in the number. Right? It's the product of the greatest power of each prime factor involved in the number. So from this the number involved is 2. From this the number involved is 3, and from 25 the number involved is 5. Now let's take the greatest power. For 2 the greatest power is 3, for 3 the greatest power is 2, for 5 the greatest power is 2. So this will be 8 into 9 into 25, which is equal to 1800. So the HCF of 8, 9, 25 is equal to 1, and LCM of 8, 9, 25 is equal to 1800. Question number 4. Given that HCF of 306,657 equal to 9, now we have to find the LCM. We know a property that for any two positive integers, A and B, HCF of A, B into LCM of A, B is equal to the product of A and B. So let's see. So HCF of 306,657 into LCM of 306,657 is equal to 306 into 657. Here we have already given HCF of 306,657 is equal to 9. So let's substitute in equation number 1, and we get 9 into LCM of 306,657 is equal to 306 into 657. Now taking 9 to RHS, we get LCM of 306,657 is equal to 306 into 657 divided by 9, because since 9 was multiplication, here when it is taken to the other side it becomes division. So 9 we can divide 306, 9 how much times? 9 3s are 27, again 3, 9 4s are, okay, 34. So it is 34 into 657, which is equal to 22338. So the LCM of 306,657 equal to 22338. Question number 5.
check whether 6 of n can end with the digit 0 for any natural number n. A similar question we have encountered in our example number 1. So let's do this. If number 6 raised to n ends with the digit 0, then it should be divisible by 5, as we know that any number with unit place either 0 or 5 is divisible by 5. So the prime factorization of 6 of n is equal to 6 can the smallest prime number that can divide 6 is 2, 2 3s are 6, 3 itself is a prime number, so 3 1s are 3. So 2 into 3 bracket raised to n, since it is 6 raised to n, so 6 can be written as the product of prime factors 2 and 3 raised to n. So here we can find that it is not divisible by 5. Therefore, the prime factorization of 6 of n does not contain the prime number 5. So we can say that there is no natural number n for which 6 of n ends with the digit 0. So I hope you understood this. Question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So what are composite numbers? Composite numbers are natural numbers which are divisible by 1, the number itself, and any other numbers are called composite numbers. So composite numbers can have factors other than 1 and itself. So let's see the first one, 7 into 11 into 13 plus 13. From this we can take 13 as a common term. So it becomes 7 into 11 into 1 plus 1. So this can be written as 13 into 77 plus 1, which is equal to 13 into 78. Since 78 is a composite number, 78 can be written as a product of prime factors. 2 is the smallest prime number that can divide 78. It will give us 39. Next, 3 is the smallest prime number that can divide 39. It is giving 13. 13 is a prime number, so we can divide 13 by the number itself. So this can be written as 13 into 2 into 3 into 13. Hence, we can say 7 into 11 into 13 plus 13 is a composite number. Let's take the next number. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. From this we can take 5 as a common factor. It will become 7 into 6 into 1 into 4 into 3 into 2 into 1 plus 1. So this will give us 5 into 1008 plus 1, which is equal to 5 into 1009. Since 1009 is a prime number and 5 is also a prime number, we can say hence
7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number, as it can be written as a product of prime factors 5 and 1009. Question number 7. There is a circular path around a sports field. Sonia takes about 18 minutes to drive one round of the field and Ravi takes about 12 minutes for the same. Suppose they both start at the same point and at the same time and they go in the same direction. Let's say they are going in this direction. After how many minutes will they meet again at the starting point? So we have to get the lowest time taken by Sonia and Ravi to complete the circular path and meet at the same starting point. So here we have to take the lowest or the least amount of time that is taken. So let's take the LCM of 18 and 12. To get the LCM of 18 and 12, let's do the prime factorization method. So 18, the smallest prime number which can divide 18 is 2. So we can get 9. 9 is divisible by 3, which is the next smallest prime number. And 3 is a prime number, so 3 is divisible by itself. So we can write 18 as the product of prime factors 2 and 3. So this is equal to 2 into 3 square, since 3 appears 2 times. Now let's take 12. Now let's write 12 as the product of prime factors. So 2 is the smallest prime number and we can divide 12 with 2, which gives 6. Again 6 can be divided by 2, which can give 3. 3 is the smallest prime number, so it is divisible by itself. So we can write it as 2 into 2 into 3, which is equal to 2 square into 3. So now LCM. What is LCM? LCM is the product of greatest power of each prime factor involved in the number. So from these two we can say the prime numbers or the prime factors that are involved in the numbers are 2 and 3. So it is the LCM is the product of greatest power. So the greatest power of 2 among these two is 2, right? So we are writing as 2 square. Now the greatest power of 3 among these two is, here it is 1, here it is 2. So the greatest power is 2. So 4 into 9, which is equal to 36. So we can say after 36 minutes, Sonia and Ravi will meet again at the starting point. So that's all for today's video. Hope you understood the concepts. If you have any doubts, please put your queries in the comment box. Thank you.